Here we are in Chapter 4, Lesson 4, and this will be a good break point in between the chapter. When we start 4-5, we're going to be graphing, and so we'd like to get a handle on these trig identities and functions before we start graphing them. I'm looking at example 1 on page 284, and it says we're going to evaluate trig functions of any angle in this lesson. Example 1 says, let negative 3, 4 be a point on the terminal side of theta. And so we've drawn that here. We have the x and y axis. And it says to find the sine, cosine, and tangent. So what I always like to do is draw that line down to the x-axis. We can see we have the point negative 3, 4. We know that the cosine of theta is our x value, and the sine of theta is our y value, and we know that the radius is equal to the square root of negative 3 squared plus 4 squared, and we know that 9 plus 16 is 25, so our radius is equal to 5. That's why we've jumped out of the unit circle. We see that a radius is 5. Well, if our sine is 4, the sine is opposite over hypotenuse. The sine of theta, y over r. The y value over the radius, that would give us 4/5. And the cosine of theta, adjacent over hypotenuse, that's our value x over r, that would give us negative 3/5. And we're also asked to find the tangent. The tangent is y over x. And if we look at what we have here, the tangent of theta would simply be our y value in our ordered pair over our x value. Tangent of theta being negative 4/3. Please try number 11, and we'll come back and talk about that. So we start again. This is very similar to the practice problem that we just did. We know that our x value is 4 this time. Our cosine of theta is 4, the x value. Our sine of theta is 3. And again, we have 3 squared plus 4 squared, 9 plus 16, 25, square root of which is 5. And now we can define all of the values, all of the functions of the identities. That's not what I wanted to say. We want to do this. Find the exact values. I want to get the directions right, so we get used to that. So the tangent we understand to be opposite over adjacent, or y over x. So we know the tangent of theta would give us 3/4. We know that sine and cosecant are reciprocals, 3 over 1, so that would give us 1 over 3. The secant and the cosine are reciprocals, 4 over 1 yields 1 over 4 for a reciprocal, and the cotangent being the reciprocal of tangent. So that would give us 4/3. At the top of 285, we want to talk about the signs of the functions in the different quadrants. Well, we understand sine is y, cosine is x, and tangent is y over x. So we can quickly and easily see the signs of those values. We understand that the x value in quadrant 1 is positive. The y value in quadrant 1 is positive, and therefore the ratio of the two would give us a positive value. The sine, or the y value, in quadrant 2 is still positive, the sine of y. The cosine, however, we've come back on the x-axis. The cosine in the second quadrant is negative, therefore the tangent, the ratio of the two, y over x, is negative as well. In quadrant 3, we can see the sine is now a negative y value. The cosine, as in quadrant 2, we're still on the left side of the origin, is a negative value, which gives us a tangent value that becomes positive, the ratio of sine to cosine. And finally, in the fourth quadrant, we talk about the sine, the y value, being negative. It's below the x-axis. The cosine switches back to positive. We're on the right side of the origin. And the tangent, the ratio of those two, negative to positive. Let's take a look at example 2. It says, given that the sine of theta is negative 2/3, and you can use your unit circle, the orange sheet that I just gave you yesterday. That was on Wednesday. It says tangent of theta is greater than 0. Find the cosine of theta and the cotangent of theta. So it says sine is negative. If we go back one page, it says sine is negative. So we see the sine being negative in either the third or the fourth quadrant, and we know that tangent is positive in the third and negative in the fourth. So let's see what that means for us now. So the sine is negative 2. Sine of the angle. So we have the sine being negative, but the tangent being greater than 0 and giving us a positive for the tangent. And we know that quadrant 3 is the only place where both of those two things happen. So now we have an angle. And we're given a negative 2/3 value. We know that sine of theta is the ratio y over r. We know that r, the radius, has to be a positive value so that we can understand this, the sine of theta, opposite, negative 2/3, which allows us to find the cosine and the cotangent, because right now we have this fact. 3 squared is equal to 2 squared plus adjacent squared. So we have 9 minus 4 is equal to a squared. Our adjacent value is equal to the square root of 5. Negative square root of 5, because we're going in the negative x direction. So with that information, we can come up with the cosine. Cosine is defined as x over r. So we can quickly see that instead of x in there, we should have put a 5. Square root, negative square root of 5. And to find the cosine, the x value, negative square root of 5 over 3, would give us the cosine of that angle. We can calculate that decimal value. And the cotangent would be x over y, the reciprocal of tangent, and we can see that we would get negative square root of 5 over negative 2. And calculating those decimal values. Let's try problem number 29 and come back here and talk about it. Tangent, negative 15/8. So in problem 29, we see that we have a negative tangent value, also that the sine is negative. And if we go back to this page right here, sine is negative, tangent is negative. That means we have only this situation. Sine is negative, tangent's negative. Notice everywhere else we don't have that condition. So we're going to be working in the fourth quadrant. And we know this, that the tangent of this angle, draw our reference triangle there, tangent is opposite over adjacent. So we can place those values in. We can also quickly see that negative 15 squared plus 8 squared is 225 plus 64. 225 plus 64. 289. We take the square root of that, and we should have a 17. 289. So we can see that the hypotenuse is 17. Now it's the easy part. We've got the tangent. We can figure out the sine quickly. We're looking at this reference angle. So the sine of theta, opposite over hypotenuse, negative 15/17. Cosine is the x adjacent over hypotenuse, 8 over 17. The tangent we were given. The cotangent is the inverse, the reciprocal of tangent, and for that we had negative 8, negative 15/8, so we would have negative 8/15. Cosecant is the reciprocal of sine. That would give us negative 17 over 15. The secant is the reciprocal of cosine, 17 over 8. And that would conclude all 6 trig values.